Welcome you all. I am Dr.N.S. Senthur, Assistant Professor, Department of Mechatronics, Bharat Institute of Higher Education and Research. The course code U18Oemt002 and course name Non-Destructive Testing. Today's topic Liquid Penetrant Testing. So the basic principle of liquid penetrant testing is that when a very low viscosity like highly fluid or liquid, the liquid we call as a penetrant is applied to the surface of a part. It will penetrate into holes and voids open to the surface. Once the excess penetrant is removed, the penetrant trapped in this voids will flow back out and creating an indication. The penetrant test can be performed on magnetic and non-magnetic materials, but does not work well on porous materials. The penetrants may be visible, it's meaning they can see in ambient light or fluorescent, requiring the use of the black lights. The liquid penetration testing, one of the major requirements is the penetrant. Based on the penetrant, we can check the defects of the material. See, in the major disadvantages of that liquid penetration testing method, we cannot use in porous materials. Other than materials like magnetic or non-magnetic or metallic, whatever the materials we can use in the testing method. It's one of NDT testing method. It's a basic testing method also. Okay, this is an example of the visible eye penetrant test process. If you fill it, the porous or non-porous material. Here we are using in this method only we can use non-porous materials. So metal or non-metallic metal, we are using the penetrant. We can find out where the gap and where the defects are with that. That we can find out use of the visible dye penetrant process. When the performing the penetration testing inspection method, it is important that the surface being tested is clean and free of any foreign material or liquid that might block the penetrant from entering voids and open to the surface of the part. After applying the penetrant, it is permitted to sit on the surface of a specified period of time. It's called the dwell time. So very important point in that testing method is dwell time. We need to apply the penetrant, sit on the surface for the specific period of time. Then the part is carefully cleaned to remove the excess penetrant from the surface. Okay, when removing the penetrant, the operator must be careful not to remove any penetrant that has flowed in the voids. So if you remove the voids penetrant, what will happen? We cannot be able to find the particular correct size of the measurement of the cracks or gaps or defects. Okay, so we need to remove the penetrant. The operator must be careful not to remove any penetrant that has followed in the voids. A light coating of developer is then be applied to the surface and given time. The developer's dwell time is at the given time to allow the penetrant from any voids or shows to shape up into the developers, creating the visible indication. Following the prescribed developer dwell time, the part is inspected visually with the aid of black light for fluorescent penetrants. Most of developers are fine grained and white talcum-like powder that provide a color contrast to the penetrant being used. So liquid penetration method First of all, the choosing the penetrant is very important, and applying the penetrant is very important, and removing the excess penetrant is very important. Then liquid penetration testing technique, solvent removal process. The solvent removal penetration are those penetration that require a solvent other than water to remove the excess penetrants. These penetrants are usually visible in nature, commonly dyed a bright red color that will contrast well against white developer. The penetrant is usually sprayed or brushed onto the part. Then after the penetrant, dwell time has expired. The penetrant is cleaned with a cloth dampened with penetrant cleaner, after which the developer is applied. The following developer dwell time, the part is examined to detect any penetrant bleed out showing through the developer. These are the solvent removal process. Then water washable. The water washable penetrant have an emulsifier including in the penetrant that allows the penetrant to be removed using a water spray. They are most often applied by dipping the part in a penetrant tank, but the penetrant may be applied to the large parts by spraying or brushing. Once the part is fully covered with penetrant, the part is placed on a drying board for the penetrant dwell time. Then taken a rain stations where it is washed with a coarse water spray to remove the excess penetrant. Once the excess penetrant has been removed, the part may be replaced in a warm air dryer or in front of a gentle fan until the water may be removed. The part can be placed in a dry developer tank and coated with developer or allowed to sit for the remaining dwell time, then inspected. These are the water washable process. Then next is post-emulsifiable. The post-emulsifiable penetrants. See, we are seeing about the types of penetrants. Okay, now we are seeing post-emulsifiable penetrants are penetrant that do not have any emulsifier include in its chemical makeup like water washable penetrants. The post-emulsifiable penetrants are applied in the similar manner but superior to the water washable step. The emulsifier is applied to the surface for a prescribed period of time. The emulsifier dwell time, already we discussed, right? What's meant by dwell time? To remove the excess penetrant, when the emulsifier dwell time has, that part is subjected to the same water wash and developing the process used for water washable penetrant. The emulsifier can be lipophilic. It's called by oil-based or hypophilic or water-based. So you know the emulsifier two major types. One is lipophilic, another one is hypophilic. The lipophilic, it's mostly called as oil-based. Hypophilic, mostly we called as water-based. Then general procedure for liquid penetrant inspection. So in that in liquid penetration procedure, we have some of 7 major steps are being using. The first one, cleaning the surface to be examined. So before checking, inspect the material in the liquid penetration method, first we clean the surface to be which we are going to be examined. Okay. The second one is drying the surface. We need to dry the surface. This is the second major step. The third major step is application of the penetrant. So we need to apply the penetrant in that surface of the examined surface. Okay. Then fourth measure is removal of the superfluous penetrant. Excess penetrant we need to remove from the surface. Then drying the surface, that is called by dual time, right? So we need to wait for some time for drying that surface. Then application of the developer. We are going to apply the application to developer. The last one is observation and interpretation of the indication. So these are the 7 steps we are generally following liquid penetration inspection method. The first one is cleaning the surface to be examined. Second one is dyeing the surface. Third one is application of the penetrant. And fourth one is removal of surface fluorous penetrant. And fifth one is dyeing of the surface. And sixth one is application of the developer. And last, the observation and interpretation of the indication. These are the steps you are following the liquid penetration inspection. Then areas of application of liquid penetrant. The liquid penetrant can be used for the inspection of all type of material such as ferrous and non-ferrous, conductors and non-conductors, magnetic and non-magnetic, and all sort of alloys and plastics. Most common applications are in casting, forging, and welding. These are the areas of application of the liquid penetrant. Then list of penetrant inspection can only be used to inspect for flaws that breaks the surface of the example. Some of these flaws are listed. That what are the flaws? You see, fatigue cracks and punch cracks and grinding cracks and overload and impact fractures and porosity, laps, seams, pinholes, and welds. These are the flaws we are going to be inspect. Okay. In that fatigue, quench, grinding cracks, and overload impact cracks and laps, seams, pinholes in welds. We can find easily use of liquid penetration testing method. The lack of fusion or brazing along the edge of the bond line, as mentioned above, one of the major limitation of the penetrant inspection. In that flaws must be open to the surface. Okay. The primary advantages of the liquid penetration method. The method, the first point, the method has high sensitivity to small surface discontinuities. In this method is the major advantage, high sensitivity to small surface discontinuities. Then second, the method has few material limitations. Example, material and non-metallic and magnetic and non-magnetic and conductive and non-conductive material may be inspected, not a porous material. Okay, large areas and large volumes of parts, materials can be inspected rapidly and low cost. Large areas and large volumes of parts material can be inspected rapidly and low cost. Parts which complex genetic shapes and routinely inspected. Indication are produced directly on the surface of the part and constitute a visual representation of the flaw. Then aerosol spray can make penetrant material very portable. The penetrant material and associated equipment are relatively inexpensive. So these are the major advantages of the liquid penetration method. Then disadvantages of the liquid penetration method, only surface breaking defects can be only detected. Here we cannot able to find other defects. Only surface breaking defects can be identified in this method. And only relatively non-porous surface can be inspected. Then third major disadvantage is pre-cleaning is critical since containment can mask defects. Then fourth major disadvantage is material screening from machining, grinding, and grit or vapor blasting must be removed prior to LPA, liquid penetration method. The inspection must have direct access to surface being inspected. Then next point, surface finishing and roughness can affect inspection sensitively. The multiple process operating must be performed and controlled. Post cleaning of acceptable part or material is required, and cleaning and handling proper disposal is required. These are the major disadvantages of the primary of liquid penetration method. Then a penetrant, how it was made? The penetrant must have some qualities. That is, it is spread easily over the surface of the material being inspected to provide complete and even coverage. So the penetrant, how made properties, how it was be, that only we are telling that here the spread easily, it need to spread easily over the surface of the material being inspected to provide complete and even coverage. Be drawn into surface breaking defects by capillary action. And third major point, remaining the defects but remove easily from the surface of the part. So apart from that defect, we need to easy to remove. Okay, that's the major importance of the penetrant. Then next point, remain fluid, so it can be drawn back to the surface of the part through the dyeing and developing steps. Be highly visible or fluoresce brightly to produce easy to see indications, not to be harmful to the material being tested or inspected. Okay, these are the major importance of the penetrant. The penetrant material come into two basic types. These are listed here. The type one is fluorescent penetrant, and second type is visual penetrant. Okay, the fluorescent penetrant we cannot be able to see directly. Okay, visible penetrant you can see. Then penetrants are the classified by the methods using remove the excess penetrant from the part. The four methods are listed below. The first one is water washable, second one is post-emulsifier, that is called polyphilic, and third one is solvent removable, and fourth one is post-emulsifier, that's also hypobolic. What's in the developer? Here we are going to say about developer. In the liquid penetration method, the process is developer. The role of developer is to pull the trapped penetrant material out of defect and spread it out on the surface of the part, so it can be seen by the inspector. The fine developer particle both reflect and retract the indicate the ultraviolet light, allowing more into the interest with the penetrant, causing more efficient fluorescence. The developer also allows more light to be emitted through the same mechanism. This is why the indicators are bigger than the penetrant itself under UV light. The another function that some developers perform is to create a white background. So there is a greater degree of contrast between the indication and the surrounding the backgrounds. The developer, the ASM standards, the classify developed into 6 standard norms. One is the dry powder, form is a water soluble. The third one is water suspendable, and fourth and non-appearance type, the fluorescent solvent basis and visible type basis, the specific applications. The developer classification are based on the method that the developer is applied. The developer can be applied as a dry powder are dissolved or suspended in a liquid carrier. What's dry powder? The dry powder developer is generally constrained to be the least sensitive, but it is inexpensive to use and easy to apply. Dry developers are white, fluffy powder that can be applied to a through dry surface in a number of ways. The dry developer can be applied dipping part in the container of the developer or by using a buffer to dust part with the developer. Parts can also be placed in a dust cabinet where the developer is blown around and allowed to settle on the part. Electrostatic powder spray guns are also available to apply the developer. The goal is to allow the developer to come the contact with the whole inspection area. Next topic is the water soluble. As the name implies, the water soluble developers contains a group of chemicals that are dissolved in water and form a developer layer when the water is evaporated away. The best method for applying water soluble developer is by spraying it on the part. The part can be wet or dry. Dipping, pouring, and brushing the soluble on the surface is sometimes used, but these methods are less desirable. And when developers contain wetting agents that causes the solution to function, much like dilute hyperbolic emulsifier, can be lead to additional removal of penetrant. Then selection of penetrant technique. That is the major thing here. The selection of liquid penetrant system is not a straightforward task. There are a variety of penetrant system and developer types that are available for use. And one of the set of penetrant material will not work for all applicants. Okay. Many factors must be considered when selecting the penetrant material for particular application. These factors include the sensitivity required, material cost, and number of parts, size of area requiring inspection, and portability. When sensitivity is the primary consideration for choosing a penetrant system, the first decision that must be made is whether to use fluorescent penetrant or visible dye penetrant. Fluorescent penetrant are generally more capable of producing a detectable indication from a small defect. Also, the human eye is more sensitive to light indication on a dark background, and the eye is naturally down a fluorescent indication. Under the constant condition, the visible penetrant may be better choice. When fairly large defects are the object of the inspection, a high sensitivity system may not be warned and may result in the large number of variable indicators. The visible dye penetrant have also been found to give better results when surface roughness is high or when flaws are located in area such as weldments. Since the visible dye penetrants do not require a darkened area for the use of an ultraviolet light, visible systems are more easy to use in the field. Solvent removal penetrants, when properly applied, can have highest sensitivity and very convenient to use. However, that they usually not practical for large area inspection or high volume production settings. Another consideration in the selection of penetrant system is whatever that whether the water washable or post-emulsifiable or solvent removal penetrant will be used. The post-emulsified system are designed to reduce the possibility of overwashing, okay, which is the one of the factors known to reduce sensitivity. However, the system add another step and thus the cost to inspection process. The time required to fill A flaw depends on the number of variables which include the following. The first one is the surface tension of the penetrant, then contact angle of the penetrant, then third, the dynamic shear viscosity of the penetrant, which can vary with the diameter of the capillary. The viscosity of penetrant is microscopic flaws is higher than its viscosity in bulk, which shows the perimeter of the tight flaws. The atmospheric pressure at the flaw opening, the capillary pressure at the flow opening, and the microstructure property of the penetrant. The penetrant systems are classified into 4 methods of the excess penetrant removal. These are including the following: the water washable method, post-emulsified method, and solvent method, and same post-emulsified method, the hyperbolic and lipobolic methods. So these are the basic penetrant method used in that liquid penetration process. Here we look at that the major thing, the 7 steps used in that liquid penetration method. That is the first one called by cleaning the surface to be examined. Okay. Second one is dyeing the surface. Third one is we see about the application of the penetrant. Fourth one we study about removal of surface porous penetrant. And next one, dyeing the surface and application of the developer. The last one will learn about observation of the interpretation of the indication. These are the basic easiest method to learn and check the liquid penetration inspection method and to find the cracks and leakages in the outer surface. Okay, we cannot able to use it in all the materials. You already we discussed, and then we know the porous material we cannot able to use and check the liquid penetration inspection. Okay, it's a basic inspection method. In this lecture video, we learn what is the liquid penetration method and what are the steps involved in liquid penetration method, and then advantages of the liquid penetration method and limitations of the liquid penetration method. And then finally we learn about step by step what is meant by drying, and what is meant by a dwell time. Okay, how to remove that excess material, and what are the types of penetrants we are using in that liquid penetration method, which is the best applicable in liquid penetration method in penetrant. That also we will learn here. Then how to identify the defects, that's also be in liquid penetration method, that's also we will learn. So finally we know about what is in by liquid penetration method in NDT. Okay, that one more thing, one more time I'll tell you that general procedure for the liquid penetration inspection is: first step, cleaning the surface to be examined. So before checking, we need to clean the surface of the material, and drying the surface. So drying the surface means we remove all the water molecule or whatever be, we need to remove that surface. Okay, drying the surface. Third one is applicant of the penetrant. We are going to now which penetrant we finalize. We need to apply the penetrant in that the examined surface. And fourth one is removal of the superfluous penetrant, means remove the excess the penetrant. And wait for drying the surface, we need to wait for the drying the surface. And the last step of the process is application of the developer. We need to then finally we can observe the interpretation of the indications. So in that we can check that what are the defects or we happen in that object, that we can easy to find in this process. Okay, so it have NDT, it have so much of methods like acoustic method, thermography method, so many methods are there. In that method, comparingly, liquid penetration method, very cheapest method. Comparingly, skills, low skills is needed. No need to spend money. in that inspection method, much more comparing that other methods. And only limitation is we can find only outside of the leakages or defects, surface defect only we can find out. These are the major about liquid penetration inspection method. Thank you.